All right, now we are going to cover the rest of this chapter, and we're going to jump into chapter 8 and cover some of that, and then we'll be done for the night, and I will see you next week after that. But let's not get too far ahead. All right, so real GDP. So hopefully with everything that we just covered, like you have a solid understanding of what GDP is and all the different ways that it can be measured. Super important for this course. That's why I went over it so many times. But now we're moving forward. So again, GDP is a measure of the output, but we're not taking into consideration what's happening with prices in the economy. Like, is our overall prices going up or down? So that's what real GDP is going to do. So the commonly cited GDP number is an interesting and useful statistic, one that provides a good way to compare the size of different economies, but it's not a good measure of the economy's growth over time. Even if an economy's output doesn't change, GDP will go up if the prices of goods and services the economy produces have increased. In order to accurately measure the economy's growth, we need a measure of aggregate output. So aggregate output is the economy's total quantity of output of final goods and services. The measure that is used for this purpose is known as real GDP. Whenever you see the word real in this class, it's always going to imply that we are adjusting for changes in the price level of the economy. So let's talk about calculating real GDP. So imagine an economy in which only two goods, apples and oranges, are produced. So here's quantity of apples, the prices, quantity of oranges, prices, and GDP, 1 year versus the second year. Assume that both goods are sold only to final consumers, so we're not considering intermediate goods in this simple example. So the value of sales increased from year 1 to year 2 by 50%. So in year 1, we had the value of oranges, which is the amount of oranges times their prices. So oranges, we had 1,000. Their prices that first year were 50 cents. And so the value of all oranges that first year is equal to $500. Apples that first year, we had 2,000 sold at a price of 25 cents each. So therefore, the value of apples were also $500 for that year. And therefore, GDP in this very simplified world in which only apples and oranges are produced is equal to the sum of these two values, which is $1,000. Year 2, we had 1,200 of the oranges produced. So 1,200 oranges produced. We see that the price went up by 20 cents. And so that got us to $840 in terms of value of oranges that were sold in the second year. Apples, we had 2,200 times again the price of apples, 30 cents, which brought us to a value of $660, and therefore GDP for that second year is equal to the sum of the two, which is $1,500. So the increase in the dollar value of GDP in this case overstates the real growth in the economy, the growth of our ability to produce. So part of the 50% increase that we see here, where we see $500 of increased value in our final goods and services, between year 1 and year 2 reflects just higher prices and not higher production of output. So to estimate the true increase in aggregate output produced, we ask, how much would GDP have gone up if prices had not changed? So to answer this question, we need to find the value of output in year 2 expressed in year 1 prices. So again, we've got value of year 1 stuff in year 1 prices to again be equal to 500 plus 500, oranges and apples. Now if we don't take into account the price changes and simply value how much oranges are valued at in terms of quantity, reflecting the prior year's prices, then we're going to get 1,200 oranges produced in the second year at a price of 50 cents. In that case, the value of oranges the second year is going to be $600. The value of apples in the second year is going to be equal to the amount produced, 2,200, times the price from the first year, which is 25 cents again, which then gives us a value of $550. And so therefore GDP, the second year, in year one prices, is going to be equal to $1,150. So this increase in the dollar value of GDP, overstates the real growth in the economy. So GDP measured in year one prices rose 15% from 1,000. In this case, we're talking about billions, so billions of apples. So 1,000 billion to 1,150 billion. So real GDP equals the total value of all final goods and services produced in the economy during a given year, and it's calculated using the prices of some selected base year. So in the actual measure of GDP that tells us something about the growth of the economy, we adjust for changes in the price level by choosing some base year and then using the prices from that base year to track the value of what is produced over a period of time post that base year. Now, the normal way that we've been measuring GDP, in which we're looking at the prices from a specific year, that is what we call nominal GDP. So GDP in name only, nominal, not adjusted for inflation, which is always going to be real. So that's a typo there. I should say real. Sorry about that. Type these up pretty quickly. I have a lot to do. A lot. Anyway, the value of all final goods and services, nominal GDP, is the value of all final goods and services produced in the economy during a given year, calculated using the prices current in the year in which the output is produced. So an important question is to ask, why not calculate real GDP using the prices of year 2 rather than the prices of year 1 as the base year prices? So if we were to do that, we would get 1,000 oranges, of course, in the first year, but using year 2 prices, we would get a value of $700. Apples, we have 2,000 apples produced the first year times the price in the second year. That's going to get us to $600. So real GDP, we'll calculate in a second, to be 1,300. And again, if we're using year 2 prices to price year 2 output, we'll get the same amount we got in the original calculations, which is $840 billion for the value of apples, oranges, and 2,200 or apples produced the second year times the price of apples in the second year, which is 30 cents, giving us $660. And so then we've got real GDP the first year using year 2 prices to be equal to 1,300, and in the second year to be equal to 1,500. So the percent increase in real GDP in this case using year 2 prices is going to equal the difference between the year 2 minus the year 1 value of total output as a proportion of the value of total output in the first year. So that's going to give us 200 over 1,300, which is equal to 0.154. If we multiply that by 100, that'll tell us that the percentage increase in real GDP is equal to 15.4% using the year 2 prices. So real GDP percentage increase using year 1 prices was 15%, and using year 2 prices was 15.4%. So there's a slight discrepancy there. So government economists who put together the actual U.S. national accounts have adopted a method to measure the change in real GDP, which is known as chain linking. So the method uses the average between the GDP growth rate calculating using an earlier base year and the GDP growth rate calculated using a late base year. So it takes into consideration like the different year prices. So in this case, it would look at 15% plus 15.4%, divide that by 2, get the average of the two, and that will get us to the chain-linked average real growth rate of the economy to be 15.2%. So as a result, U.S. statistics on real GDP are always expressed in chain dollars. Chain dollars, by definition, is the method of calculating changes in real GDP using the average between the growth rate calculating using an early base year and the growth rate calculated using a late base year. All right, real life, real GDP, nominal versus real GDP in these various years, 2005, 2009, 2013. We see that nominal GDP in 2005 was 13 billion roughly. Real GDP in 2009 dollars was actually 14 billion. Um, so in 2009, obviously, using the same prices, we're going to get the same number for nominal and real GDP because that's the prices we're using to measure real GDP. And then if we look at nominal, the nominal GDP is 16.7 billion, whereas the real GDP using 2009 prices for 2013 is 15.7 billion. So again, we see that we have less growth in the actual economy when we take into account adjustments in the overall price level. So it's definitely important to adjust for this, and it's a technical process. There's a lot of people that do these computations. It takes a long time to get all this data together, adjust it, get all the prices settled, and then use the right price. It takes a lot of work, a lot of people, a whole bureau. But it's an important metric, and again, it's how we measure the economy. And every country has their own methods, similar to ours. Some are different. They have different approaches, and the less developed a country is, the less reliable the data turns out to be. Because countries that are less developed want to overstate their GDP because then it makes their countries more appealing to investors. So there's a lot of complications with respect to that. So there's a political dimension to this whole measurement process as well. So what real GDP doesn't matter? So GDP, nominal or real, is a measure of a country's aggregate output. Other things equal, a country with larger populations will have higher GDP simply because there's more people working. So that brings us to this other measure called GDP per capita. So GDP per unit of people within a country, essentially. So GDP divided by the size of the population, it's the equivalent to the average GDP per person, the average amount of output per person in a country. It allows us to compare GDP across countries while eliminating the effect of differences in population size. So real GDP per capita can be a useful measure in some circumstances, such as in the comparison of labor productivity between countries. Real GDP has well-known limitations as well as a measure of a country's living standards. So real GDP per capita is not an appropriate policy goal in itself. So again, like if you are just measuring the average amount of output per person in a country, you might have like an elite class of folks that basically own all the productive capital in the economy and are reaping all the rewards of the revenues. And so even though you might have a lot of output in the country, and even seemingly a lot of output per person in the country, that doesn't necessarily reflect the amount of income that everybody is earning in the country, because a lot of that income might be going to small portions of the population. And therefore, we can't use real GDP as a means of sort of gauging differences in standards of living across countries. And that's why it says that it's not used as an appropriate policy goal. So it's not a measure that we use, to inform policy that obviously our representatives, our governments make, that are meant to sort of help, improve standards of living, whether domestically or internationally. So well-being was measured by a Gallup World Survey. So Gallup is an organization that does a lot of surveys and for a lot of different organizations. So they can do them for governments, or they can do them for companies. It depends. Whoever wants their services. Gallup is really good at collecting data on things. So they ran a survey on what's called subjective well-being, in which people are asked, how do you feel about, your overall lifestyle, how things are in your country, how happy you are. But it's a bunch of questions. It's pretty thorough. And so it kind of allows us to gauge how people feel about overall in a country about their standard of living. So well-being was measured by a Gallup World Survey that asked people to rate their lives at the current time and their expectations for the next 5 years. So data reveals three important points. So here we've got on the y-axis, we've got the percentage of the population reporting thriving well-being. So those that are like really thinking that their lives are great as a result of their living standards. And then we have GDP per capita in US dollars here on the x-axis. So here's Portugal. Like Portugal has a low level of GDP per capita, and the percentage of the population reporting thriving well-being was pretty low. Here's Sweden. The percentage of the population reporting a thriving well-being was pretty high, and they have a high GDP per capita. So what this data tells us is, one, that rich is better, that if you do have a higher level of GDP per capita, then you will have an overall higher, on average, subjective well-being. Like people are going to feel like they're doing well in their country. And we can kind of see that here. So this is a plot of all these individual data points, but you can kind of see a positive relationship there. Like as you increase the amount of GDP per capita, there seems to be sort of like an increasing relationship between that and the percentage of the population reporting as thriving. But we can also kind of see from this data that money matters less as you grow richer. So as you grow richer here, this tends to level out a bit. And also that money isn't everything. So we do have countries that are doing relatively well. So here's the United Kingdom, and then here's Japan. They both have pretty much the same level of GDP per capita, but you see that Japan has a very small percentage of the population reporting that they are thriving versus like the United Kingdom or even Canada, who's pretty much on par as well, and Finland as well. So again, money isn't everything. So these results are consistent with the observation that high GDP per capita makes it easier to achieve a good life, but that countries aren't equally successful in taking advantage of that possibility. So one way to think about this issue is to say that an increase in real GDP means an expansion in the economy's production possibility frontier, the amount that it's able to produce, given its productive resources and its existing technology. But whether society actually makes good use of that increased potential to improve living standards is another matter altogether. Your income may be higher this year than last year, but whether you use that higher income to improve your quality of life is your choice. You could just blow it on crap. You can. So Venezuela recently experienced over the last 13 years an explosion in their nominal GDP, but we see that adjusted for inflation, that their real GDP has actually stayed pretty flat. So this is just another reason why the real GDP is important to measure, because again, you can get the wrong information from nominal GDP. All right. Let's move on to price indexes and the aggregate price level. So how we measure the changing level of prices in the economy. The aggregate price level is a measure of the overall level of prices in the economy. And how we measure it is through what are called market baskets that allow us to create price indexes. So to measure average price changes for consumer goods and services, economists track changes in the cost of a typical consumer's consumption bundle, the typical basket of goods and services purchased before price changes. A market basket is a hypothetical set of consumer purchases of goods and services. So suppose that there's a frost in Florida that destroys most of the citrus harvest. So we can track the value of a market basket before the frost. So here's the typical consumer purchases of oranges, grapefruits, and lemons. This is the typical amount that they consume. The prices here of each of these three fruits are labeled before the frost and then after the frost. So remember, as far as these prices go, the actual price changes that are occurring in these individual markets have to do with just the markets that these goods are bought and sold in, so supply and demand. So if you have a frost, then that means that at any given price, suppliers are going to supply less. And so that's going to shift the supply curve to the left, it's going to lower supply. And so if this is supply and this is demand, then that's going to cause a higher equilibrium price. So that's where the higher prices come from due to the frost. So here is the value of the basket. Let's say that the market basket is just made up of these three fruits. The value of the market basket before the frost is, again, 200 oranges times the price before the frost of oranges, which is going to equal $40. And then we've got the amount of grapefruits typically bought at the old pre-frost price. Say that 5 times fast. And lemons also bought generally in quantity of 100, and here they are at the pre-frost price. So again, oranges are 40 plus 30 for grapefruits plus lemon 25. So that equals $95 for the value of the market basket before the frost. Now after the frost, again, we track the amount that are bought times the prices at that time period. Again, we've got 200 oranges at the post-frost price. Then we've got 50 grapefruit at the post-frost price of $1, plus the 100 lemons at the post-frost price of 45 cents. So that's $80 plus $50 plus $45 gets us to $175. Now, in order to figure out how much prices have gone up, we take the post-frost price as a proportion of the original, the post-frost value of the market basket as a proportion of the pre-frost value of the market basket, which was $95. And that gets us to 1.842, and that tells us that the prices after the value of the market basket after the frost was 1.842 times that of the value of the market basket before the frost. So prices in this case have increased by 84.2%. So in this example, the average price of citrus fruit has increased 84.2% since the base year as a result of the frost, where the base year is the initial year used in the measurement of the price change. So economists use the same method we just used to measure changes in the overall price level. They track changes in the cost of buying a given market basket that they choose. In addition, they perform another simplification in order to avoid having to keep track of the information that the market basket costs. They normalize the measure of the aggregate price level, which means that they set the cost of the market basket equal to 100 in the chosen base year. So working with a market basket and a base year, and after performing normalization, we obtain what is known as a price index. And the index part of it indicates that we are linking it to some base, some point of reference that we are comparing everything to. So it's indexed to some base. So the price index, formally defined, measures the cost of producing a given market basket in a given year, where that cost is normalized so that it's equal to 100 in the selected base year. It's always cited along with the year for which the aggregate price level is being measured and the base year. So whenever you're talking about a price index, you'll always mention with a base year of whatever. So a price index can be calculated using the following formula. So the price index of a given year equals the cost of a market basket in any given year as a proportion of the cost of a market basket in a base year times 100. So in the citrus fruit example, the market basket before the frost cost $95 and $175 afterwards. So the price index of year before frost was equal to 95 over 95, which is equal to 100, which is equal to 1 times 100, which is equal to 100. So the base year is normalized to 100. That was the original year before the frost, which changed the prices. And so the price index of the year after the frost was equal to 175 divided by 95. So the value of the market basket after the frost as a proportion of the value of the market basket before the frost times 100, which gets us to 1.842. We multiply that by 100. So that means that the price index of the year after the frost is equal to 184.2. So the price index makes it clear that the average price of citrus has risen 84.2% as a consequence of the frost. Price indexes are the basis for measuring inflation, the rising price levels in an economy. So the inflation rate is a percent change per year in a price index, and it's typically called the consumer price index. That's typically the index that we use to measure the changes in prices and ultimately get us to the inflation rate. So the inflation rate from year 1 to year 2 is calculated using the following formula, where we assume that year 1 and year 2 are consecutive years. So the inflation rate is equal to the difference between the price index in year 2 minus the price index in year 1 as a proportion, or divided by, the price index in year 1 times 100. So in the citrus fruit example, the inflation rate is going to equal the 184.2, the price index in the second year, minus the price index in the first year, as a proportion of the price index in the first year, 100, times 100. So that's 84.2 over 100 times 100. So 0.842 times 100, so 84.2%. So we had 82.4% inflation between year 1 and year 2 as a result of the frost. So this is how we measure inflation. This is a simple example of the more complicated way that we measure inflation in the overall economy by choosing a basket of goods and then doing these exact calculations. Typically, a news report that cites the inflation rate is referring to the annual percent change in the consumer price index. Let's talk about this consumer price index. So the consumer price index, also known as the CPI, measures the cost of the market basket of a typical urban American family. It's constructed to represent the consumption of a typical family of 4 living in a typical American city. The base period for the index is currently 1982 through 1984. The index is calculated so that the average of consumer prices in these years is equal to 100, again normalized for this base year range period that they use. To calculate the CPI, the Bureau of Labor Statistics sent its employees out to survey some 23,000 retail outlets in 87 cities. Every month, it tabulates about 80,000 prices on everything from romaine lettuce to medical checkups. So this is the 2010 CPI makeup. You've got, out of the market basket, you've got a large portion of it being housing. So housing is one of the strongest sort of elements within this market basket that tells us what is happening to overall prices in the economy. And we know that the housing market is weird, generally. It goes up and down a lot. And so that has a lot to do with the instability in our economy at times when that is happening. Of course, we have other important things as well. Food and beverages, 15%. Education and communication, 6%. Recreation, 6%. Medical care, 7%. Transportation, 12%. Motor fuel, 5%. Apparel, 4%. So a lot of the things that we all buy are included in the market basket, and it's a fairly realistic gauge of what's happening in the overall prices of things that we tend to buy in an economy. Nearly every country calculates a price index similar to the CPI. So this is ours, tracking it back from 1913 through 2013, and we can see that we've had a fairly steep increase throughout the last century, which is reflected, of course, in the prices of the things that we buy. You often hear of like gas costing like 5 cents a gallon type of thing earlier in the last century, and things obviously are a lot more than that. The cost of gasoline is a lot more than that, but things in general cost a lot more than that, and this is an indicator of that, and this is how we're able to gauge it through this tracking of the CPI. Now, other countries, they do their own thing. In poor countries where people spend where people must spend a high proportion of their income just to feed themselves, food makes up a large share of their price indexes. Among high-income countries, differences in consumption patterns lead to differences in price indexes. The Japanese price index puts a larger weight on raw fish and a smaller weight on beef than our own. The French price index puts a larger weight on wine. Of course, there are other ways of measuring the price level in an economy. Two other price measures that are widely used to track economy-wide price changes include one, the producer price index, and that measures changes in the prices of goods purchased by producers. So remember, producers purchase goods from each other. They purchase capital goods to produce. They purchase machinery, buildings, etc. Commodity producers are relatively quick to change prices when they perceive a change in overall demand for their goods. So the PPI often responds to inflationary or deflationary pressures more quickly than the CPI, and therefore it might actually be a better gauge of what's happening in prices in the economy. Sometimes when prices are going up in the economy, like your standard goods won't be adjusting their prices as quickly as the prices of the goods that firms buy. So the PPI is often regarded as an early warning signal of changes in the inflation rate. We also have what's called the GDP deflator. So for a given year, the GDP deflator is 100 times the ratio of nominal GDP to real GDP in that year. Real GDP is expressed in 2005 dollars. Thus, the GDP deflator for 2005 would be equal to 100. So you would have basically nominal over real GDP being equal to each other. So that's 1 times 100. That means the GDP deflator for that year would be equal to 100. If nominal GDP doubles, but real GDP does not change, the GDP deflator indicates that the aggregate price level has doubled. So the most important point about the different inflation rates generated by these three measures of prices is that they usually move closely together. So here we see all three of the measures tracked from 1930 to 2013. And the red is the PPI, the producer price index. The blue is the GDP deflator, and the green is the CPI. And of course, they pretty much move the same. There's some variation there, but it's pretty similar. All right, let's do a practice short answer question, and that'll finish off the chapter here, just to sort of solidify our understanding of how to measure inflation. So like I mentioned last time, the Economist magazine, they do like this thing where they like look at the price of Big Macs across countries, just to kind of gauge their inflation versus like the value of their currencies. Something we'll get more into as far as like the value of currencies between countries at the end of the semester. But it does provide an interesting gauge of inflation in the countries relative to other countries. So each year, The Economist publishes data on the price of the Big Mac in different countries and exchange rates. The accompanying table shows some data used for the index from 2007 to 2011. Use this information to answer the following questions. So the first question is, where was it cheapest to buy a Big Mac in US dollars in 2007? So here we have Argentina, Canada, the Euro area, Japan, the United States. Here's 2007, here's 2011. Here's the price of Big Macs in their local currency. So Argentina has pesos, Canada has their own currency. The Euro area has the euro, Japan has the yen, and obviously the United States has the dollar. So as far as like measuring the price of Big Macs in just US dollars, then we are able to answer the question by just looking at this column here, right? So where was it cheapest to buy a Big Mac in US dollars in 2007? In Japan, right? So that's $2.31. That is the lowest price for the Big Mac. Where was it cheapest to buy a Big Mac in US dollars in 2011? In the United States, right? All right, so using the increase in the local currency price of the Big Macs in each country to measure the percent change in the overall price level from 2007 to 2011, which nation experienced the most inflation? And did any of the nations experience deflation? Great. All right, well, let's answer the first part first by doing the computations, because that's what I want you to get down. I want you to get the computations down. All right, so let's look at Argentina. So in Argentina, we're going to look at the 2007 price in their local currency for the Big Mac, which is $8.25. Then we're going to look at 2011. In this case, it's going to be 20 pesos, or pesos, however you want to pronounce it. So the change here is going to be 11.75. So we're going to look at the percent change. The base year we're going to look at is 2007. So we're going to have the change in price as a proportion of the base year times 100 to get the inflation rate. So we have the change in price, again, the difference between the 2011 price and the base year. So we have 20 minus 8.25, which is 11.75. We take that as a proportion of the base year price, and we multiply that by 100. That tells us that they had an inflation rate of 142%. Yeah, pretty high. Argentina, in fact, is known to have very high inflation, called hyperinflation, which has been a big reason why they have not been able to grow as fast as other countries. All right, so Argentina is 142%. Canada. So we're going to take, again, the difference between the 2 years. So we're going to have a change of a 110. I believe they have Canadian dollars is what they just call their currency. So they have increased the cost of their Big Mac in their local currency by $1.10 in Canadian dollars. We take that as a proportion of the base year price. So 110 as a proportion of the base year price, which is 363. Multiply that by 100 to get the inflation rate. In this case, it's going to be 30% for Canada. For the euro area, we do the exact same thing. So we've got 294 pounds in 2007, 344 pounds in 2011. Take the difference. It's only half a euro. Take that as a proportion of the base year price. So the change in the price over the base year price times 100 to get the inflation rate. 17% inflation. Japan, again, 280 yen up to 320 yen. So the difference there obviously is 40, right? So we take that as a proportion of the base year price, multiply it by 100, and that's going to get us to 14%. So they had 14% inflation in Japan based on the Big Mac index. And then finally in the US, $3.22 base year went up to $4.07, took the difference, which is 85 cents. Take that as a proportion of the base year, which is $3.22, multiply by 100 to get the inflation rate. In this case, it's going to be equal to 26%. So the US had 26% inflation. So which nation experienced the most inflation? Argentina, right? It's pretty obvious. Did anybody experience deflation? No, nobody experienced deflation. All right, so practice these computations. Make sure you're able to do this stuff. Yeah, the prices would have gone down. All right, so Argentina. All right, finally, we are moving on to Chapter 8, Unemployment and Inflation. So we'll get through unemployment, and then we will call it a day. So what we're going to learn in this chapter, we're going to learn how unemployment is measured and how the unemployment rate is calculated, that measure that you always hear about in the news. The significance of the unemployment rate for the economy, what it means. Again, when we're talking about how we measure the economy in Chapter 6, when we just introduced these concepts, both the GDP and the unemployment rate were the main measures that we used to gauge how the overall economy was functioning. And so this is the second most important measure that we're going to be covering here. So it's good to understand it inside and out. So we're going to talk about the relationship between the unemployment rate and economic growth. We'll talk about the factors that determine the natural rate of unemployment, some natural amount of unemployment that is just a characteristic of an economy, because people are sometimes between jobs, or like maybe you might have different sectors that are acting weird relative to the rest of the economy. Like, you know, when we transitioned into the digital age, like the physical film industry, like that was like dominated by like Kodak and firms of that sort, like they basically were wiped out of existence. So that's a whole sector of the economy that was just like gone, and all those people were unemployed all of a sudden. It's what's called creative destruction within the economic theory. Whenever you advance in an economy and its ability to produce, you're going to have some casualties. So anyway, so there is a natural amount of unemployment that just comes along with just a normally functioning economy. Like right now, our unemployment rate is like 4.6%, but we're doing really well. So that 4.6% is a good gauge of like the natural rate of unemployment right now. We'll talk about then also inflation. So this chapter covers unemployment and inflation, but inflation is what we'll cover next time. But there are economic costs to inflation. As the price level goes up, it does affect certain things in the economy that are going to potentially be a problem as far as our ability to maintain economic activity. We'll talk about how inflation and deflation creates winners and losers. So we'll talk about that. We'll talk about why policymakers try to maintain a stable rate of inflation. So that measure that we just looked at and how we calculate it, it's obviously very important to us as far as like telling us what's happening in the economy. And so there's like a policy goal with central banks to kind of always keep inflation at roughly 3% a year. That's sort of like the target. And we've been coming actually under that recently. So those are issues that we'll talk about throughout the semester, but it's just good to understand that there is a reasonable amount of inflation that does work within the economy. All right, so let's talk about the unemployment rate. So the U.S. unemployment rate in 2016 was 4.9% in June of 2016. So here is the unemployment rate tracked from the post-World War II era, 1948, through 2014. These bars you see here represent contractions of the economy, so recessions. Remember, there were 4 stages of the business cycle, which are short-run fluctuations in the economy. We have expansions, we have peaks, we have recessions, we have troughs. So these blue bars again represent recessions, contractions, and as we see, the unemployment rate tends to go up during those periods. Of course, that's because the economy is contracting. That means that there's less being produced. That means that more people are going to be out of jobs. 2000, unemployment rate went up. 2010, which is post-2008, it went up significantly. And that was one of the big alarming sort of signals that we really had to act like as actively as we possibly could in order to, put off like another kind of contraction like we saw during the 30s. So it was like a big red flag for us. All right, so here we have the unemployment rate for the last few years. Currently, it's at 4.9% as of June of 2016. Here's the unemployment rate of the U.S. overall. We see the unemployment rate of the United Kingdom is this orange bar right behind it. So the developed countries, they tend to kind of move together because now we are so interconnected that our economies tend to fluctuate in very similar ways. And that's why when this whole Brexit thing occurred a couple of months ago, that actually started to affect our economy as well, when people started to kind of retract from Britain, and overall, like, investors started to get nervous about like this breaking of this trade pact that allows for more trade and more overall production and consumption, that was getting somewhat compromised, and so people started getting nervous. And of course, that's going to directly affect the British economy, but definitely also started to affect us and all the other developed nations, all the European Union nations, of course, and then other developed countries as well, Canada. This green line here represents the unemployment rate for California. So the unemployment rate for California tends to be higher than the national average. All right, so let's talk about defining and measuring unemployment. So employment is defined as the number of people currently employed in the economy, either full-time or part-time. So part-time workers are included as employed. Unemployment is a more subtle concept. So just because a person isn't working doesn't mean that we consider that person unemployed. So the U.S. Census Bureau, the federal agency tasked with collecting data on unemployment, consider the unemployed to be those who are jobless and are looking for jobs and available for work. Unemployment is defined as the number of people who are actively looking for work but aren't currently employed. So if you're not looking for work, you're not included in the unemployment rate. So we'll talk about that right now. There's different categories. The labor force is the sum of those that are employed and those that are unemployed. So people that are working and people that are looking for work is how we define the labor force. Again, you can have your own ideas about like what terms mean, but in a class like this, you have to sort of let in the definitions that are used within the formal discipline in order to understand the discipline itself. So, like, be mindful of like the specific words that are used to define these things, because they are going to provide you insights into the concepts that we use in this class that are independent of what you might know about these concepts yourself already. And so don't rely on intuition. Learn the terminology of this class, learn the definitions of this class in order to do well in this class and understand economics. All right, so the labor force, again, is the sum of those employed and those unemployed, and the unemployed are folks that are looking for work but cannot find work. The labor force participation rate is the percentage of the population age 16 or older that is in the labor force. So the labor force participation rate, again, is those that are employed or unemployed, again, looking for work but can't find it, as a proportion of the population age 16 or older. That's the labor force participation rate. Multiply that by 100, that will get us that number. The unemployment rate is the percentage of the total number of people in the labor force who are unemployed. So the unemployment rate equals the number of unemployed workers as a fraction of the labor force. Times 100. So to estimate the numbers that go into calculating the unemployment rate, the U.S. Census Bureau carries out a monthly survey called the Current Population Survey. It involves interviewing a random sample of 60,000 American families. I believe that the families are rotated, so like they'll have like a certain amount of families over a certain period of time, and after a few cycles, they'll drop them out and they'll bring in new families. People are asked whether they are currently employed. If they are not employed, they're asked whether they've been looking for a job during the past 4 weeks. The results of this survey are then scaled up to represent the entire economy, or the entire population of the U.S., using estimates of total population to estimate the total number of employed and unemployed Americans. So let's talk about why this is important. The significance of the unemployment rate. The unemployment rate is a good indicator of how easy or difficult it is to find a job given the current state of the economy. Although the unemployment rate is a good indicator of current labor market conditions, it's not a literal measure of the percentage of people who want a job but can't find one. So let's talk about how the unemployment rate can overstate the true level of unemployment. If you are searching for work, it's normal to take at least a few weeks to find a suitable job. So a worker who's confident about finding a job but has not yet accepted a position is counted as unemployed. As a consequence, the unemployment rate never falls to zero, even in boom times when jobs are plentiful. So again, you're going to have people that are like between work and like know that they can find a job but taking their time, and like therefore like it, that'll muddy the waters of the effectiveness of the signal that the unemployment rate is. Let's talk about how the unemployment rate can understate the true level of unemployment. So frequently people who would like to find work but aren't working still don't get counted as unemployed. So remember, they have to answer that question by the U.S. Census Bureau on the current population survey that asks them, have you been looking for work in the past 4 weeks? So if they're not working and they answer no, then they're not counted as unemployed. So you might have discouraged workers. These are non-working people who are capable of working but have given up looking for a job given the state of the job market. So that's one type of worker that you can have that is excluded from the unemployment rate and therefore understates the true unemployment rate in the economy. Discouraged workers are part of a larger group that are called marginally attached workers. Marginally attached workers would like to be employed and have looked for a job in the recent past, but are not currently looking for work. They too are not included when calculating the unemployment rate. And you also have the underemployed, the number of people who work part-time because they cannot find full-time jobs. So those people are not included as unemployed. They're actually included as employed because they're working part-time. But they want to be working more than they actually are. And so that is a sign that there's something wrong with the labor markets there. But obviously the unemployment rate doesn't capture that. Again, they are counted in the unemployment rate. So the Bureau of Labor Statistics is a federal agency that then takes the information from the current population survey and calculates the official unemployment rate. So again, the Bureau of Labor Statistics is part of the U.S. Department of Labor. It also calculates broader measures of labor underutilization that include the three categories of frustrated workers: the marginally attached workers, the underemployed, and the discouraged workers. So here we see the three measures of unemployment, including the discouraged workers in this blue line here. That's above the normal unemployment rate. And then we've got the yellow line that represents adding the marginally attached workers. And then we've got the red line that represents adding involuntary part-time workers. Obviously, we see that the measures move pretty close together. So as far as like the movements, it doesn't matter which one you're using. It's telling us what's happening as far as like ups and downs in the labor market overall. But obviously, the unemployment rate does understate the unemployed, the people that are not working in the economy. So the broadest measure of unemployment and underemployment, which is known as U6, is the sum of these three measures plus the unemployed. U6 and the unemployment rate move very much in parallel, so changes in the unemployment rate remain a good guide to what's happening in the overall labor market. It's important to acknowledge that the unemployment rate varies greatly among demographic groups. So again, unemployment rates are representative of a representative sample of households that is then scaled up to try to capture the overall behavior of the economy. But obviously, the population of the U.S. is diverse. There's different classes of folks. There's different ethnicities, and there's different patterns in those groups with respect to the amount that they are employed. So we can look at some of that data here. So jobs are generally easier to find for more experienced workers, and for workers during their prime working years from ages 25 to 54. So here we have the unemployment rate in 2007, which is blue, 2010, which is red, 2014, which is yellow, for the overall U.S. population, for the African American population, for a white teenager, and for an African American teenager. And so we see dramatic differences here, obviously, if we zero in on specific groups. Again, age plays a big role, and obviously race can also play a big role. So even at times when the overall unemployment rate is relatively low, jobs are hard to find for some groups. African American teenagers, 2010, 44.5%. White teenagers, 22.9%, twice as much as white teenagers. So you should interpret the unemployment rate as an indicator of the overall labor market conditions, not as an exact literal measure of the percentage of people unable to find jobs. So again, like, these measures are meant as signals. They're meant to sort of give us an indication of what's happening, but we cannot use them to say, flat out, this is what is happening. Like, we have to be more specific if we want to provide detailed analysis of what's actually happening on the ground to people in various communities. All right, let's talk about economic growth and unemployment. We're almost there, folks. So it's important to recognize that economic expansions aren't always periods of falling unemployment. So here we have, again, some unemployment time series data. Time series data is data that is tracked for a measure over periods of time. That's what we call time series data. So we have time series data here for the unemployment rate from 1979 to 2014. And again, the blue bars represent contractions in the economy, recessions. And again, we see that the unemployment rate is going up when there are recessions. But we also see that once the recessions are over, that oftentimes we will continue to see an increase in the unemployment rate. So the unemployment rate can continue to rise even after recessions end. The explanation is that although the economy is growing, it's not growing fast enough to reduce the unemployment rate. So you have what's called a jobless recovery, a period in which the real GDP growth rate is positive, but the unemployment rate is still rising. Generally, there's a negative relationship between economic growth and the unemployment rate, though, in general. So here on the horizontal axis, we have the annual growth rate of real GDP, the percent by which each year's real GDP changed compared to the previous year's real GDP. And the vertical axis measures the change in the unemployment rate over the previous year in percentage points. So last year's unemployment rate minus this year's unemployment rate. So here we have different data points from different time periods. And we see that if the change in unemployment rate is high, and we're going to have a low change in real GDP, but at periods where the unemployment rate change is low, then we will also, so we're going to have, we'll have high rates of change of real GDP. So again, that generally captures the fact that there's a negative relationship between the economic growth of an economy and the unemployment rate. So the increasing capacity of the economy to produce tends to be obviously stunted when there is unemployment. It's a relationship that's interesting, kind of obvious, but tends to break down sometimes. This is one of the big sort of challenges of macro in general, is that you'll have things like this, and then economists will provide these results to like policymakers, and policymakers will of course want to enact certain policies in relation to this stuff. But politics is an arena where obviously people have intentions that are not always meant to sort of help everybody. They're sometimes meant to just help themselves. And so oftentimes when you see sort of breaks in these relationships, those that are looking to enact policies that will benefit maybe a small amount of people or versus the entire population, will like just eat at those cracks and just say, well, this relationship is not valid. You can't use it as justification for these policies that are meant to enact growth. You should not spend all this money here to try to help the economy because this data is misleading, etc. So that's why you'll often hear of disagreements that occur within the economic community, occurring mainly in the macro arena because it has such a big influence over policy versus microeconomic analysis that tends to focus on individual industries, small parts of the economy that don't necessarily play a big role in the larger policies that we all hear about and tend to affect our lives. And again, those are the policies that are often the ones that are most contentious because it involves questions of how much the government should spend to help people that are in need versus cutting taxes to the rich and this whole back and forth about that. And so things like this are often used to sort of muddy the waters of debate. So if you were to get further in the discipline of macroeconomics, you're going to see a lot of sort of papers that are published to sort of try to undermine clear-cut results or things that seem clear-cut that, again, are meant to help those that are interested in enacting policies that are not meant to help the whole, but small parts. All right, let's do a quick multiple choice question. Change in the unemployment rate. Very simple question. In the time series graph, as we move from the beginning of 2001 to the beginning of 2003, we see that the unemployment has, so we're going from 2001 to 2003, A, decreased from approximately 5% to approximately 4%. B, increased from approximately 5.3% to approximately 7.3%. C, decreased from approximately 7.7% to approximately 5.5%. Or D, increased from approximately 4% to approximately 6%. D, right? All right. Very simple question. You were able to identify what the change was based on the time series graph, which means that you are able to read a graph. Good. It's important. You need to be able to read graphs in this class. All right. It is D. All right, practice short answer. Defining unemployment. In the following case, is the worker counted as unemployed? Rosa, an older worker who has been laid off and who gave up looking for work months ago. No, right? Because she's not looking for work, even though she's not working. So Rosa is not counted as unemployed because she's not actively looking for work, but she is counted in broader measures of labor underutilization as a discouraged worker. She stopped looking for work. Anthony, a school teacher who's not working during his 3-month summer break. No, right? Because he still has a job. Anthony is not counted as unemployed. He's considered employed because he has a job. Grace, an investment banker who has been laid off and is currently searching for another position. Yes, exactly. Grace is unemployed. She is not working and is actively looking for work. Sergio, a classically trained musician who can only find work playing for local parties. So Sergio is not unemployed, of course, but underemployed. He is working part-time for economic reasons. He's counted in broader measures of labor underutilization. Natasha, a graduate student who went back to work because jobs were scarce. Right? She is not counted because she is not looking for work. She is what's called marginally attached. She is, again, counted in these broader measures of labor underutilization. She's a marginally attached worker who would like to be employed and have looked for a job in the recent past, but are not currently looking for work. Marginally attached workers. All right. All right, let's call it a day, folks. Have a good night. I'm going to open up chapter 7's homework. And that's it. So I'll see you guys next week. Have a good week. All right, have a good one. Happy birthday, man. Thanks.